In the previous video, I shared with you one sample hypothesis test, and in this video, I'll be sharing with you two sample hypothesis tests. Yeah. Um, it would be good if you can watch the video on one sample hypothesis test before you watch this video, because both these procedures, of running the test is almost similar, and it will provide you some idea on a better idea, on how to do two sample hypothesis tests. Now, for two sample hypothesis tests, we want to talk about two groups. And these two groups are different. We have group that is independent. Okay, it has a different characteristics, and we have group that is dependent. Let's look into this group one by one. For the independent group, for example, we have group A and we have group B. So what we do is that we take a sample from group A, sample X. We take a sample from group Y. So both the sample are going to have their respective mean. So what we are trying to do is we want to find, is there any difference in these two groups? That's what we are testing. And these two groups are independent and they are not related to each other. Let's look into some examples. COVID-19 test kit developed by South Korea. We have one group. COVID-19 test kit developed by China. One group. So what is the issue here? Malaysia Health Ministry is using COVID-19 test kits both from South Korea and China. And they received information that test kit from South Korea takes longer hours to produce results as compared to test kit from China. So from these two groups, we already know that the test kit from South Korea gives you a longer time, to generate the results, and test kit from China takes a shorter time to produce the results. So the Malaysia Health Ministry wants to test this thing, because if they're buying from two different parties, so it'll be better if they just buy test kit developed by China if it's giving you results much more faster. So before they drop South Korea and only buy from China, they need to test the hypothesis first. Which hypothesis? Here. Test kit from South Korea takes longer hours to provide results as compared to test kit from China. So what we will do is that we take a sample of patients that were tested using the kit from South Korea, and we will take a sample of patients who were tested using the kit from China, by looking into how long it takes to generate the results. So if we say the South Korea kit takes a longer time as compared to China, then definitely mean 1 is going to be bigger than mean 2, right? So this is what we want to test, right? That kits from Korea takes longer time as compared to kits from China. So mean 1 minus mean 2 should give you a positive value, because this is greater than mu 2, right? So mu 1 minus mu 2 should give you a positive value. It means it's greater than 0. So whenever writing hypothesis for two sample mean, I prefer writing the alternate hypothesis first, because this is what we want to test. So can you see, mu 1 takes longer time minus mu 2 takes shorter time. The mean is going to be greater than 0. So automatically my null will be mu 1 minus mu 2 is lesser than or equal to 0. And if you look into the symbol that we are using in the alternate is greater than, therefore it's upper one-tailed test. Let's look into another example. Over here we have two suppliers. We have supplier A, who is also supplying COVID-19 test kit, and we have supplier B, who is also supplying the COVID-19 test kit. Let's see what is the issue here. Malaysia Health Ministry is buying COVID-19 test kits from two suppliers. and they found that supplier A has a shorter delivery time. That means, what do they mean by shorter delivery time here? By the time they order and by the time the product arrives. Yeah, so they have a shorter delivery time. Yeah, as compared to supplier B. Yeah, so supplier A, if you order, you can get faster as compared to supplier B. So again, probably, if you look into our present scenario, we are running out of the kits. Yeah, and we need the kits much more faster. So if supplier A can give us the kits much more faster, then why should we buy from B, right? But however, before making the decision, we need to test the hypothesis. So what are we trying to say? The mean over here for supplier A, yeah, the delivery time is much more shorter compared to B. So supplier A is shorter, supplier B is longer. Mean 1 is smaller, mean 2 is bigger. So mu1 minus mu2, it will give you a negative value, yeah, because the value here is smaller. Here is a shorter time compared to B, which is a longer time. So I would want to write my alternate hypothesis first. Mu1 minus mu2, it will be smaller than 0. Why? Because the value is going to be negative. Yeah, and then I will write my null hypothesis, which is mu1 minus mu2 is greater than or equal to 0. And if you look into the sign over here, the symbol over here is less than. Therefore, it's going to be lower one-tailed test. A final example, we have two groups. We have the private hospitals and we have the government hospitals. The private hospitals claim on average 14 days of treatment is required for patients to recover from COVID-19. Government hospitals claim on average 14 days of treatment is required for patients to recover from COVID-19. Both are claiming the same thing. Malaysia Health Ministry wants to test whether the average recovery period is different from 14 days in both groups. So we are trying to say this is what they claim, but we want to say no, they are different. So if they say it's the same, if we pick a sample of patients who have recovered from private hospitals and if we take a sample of patients who have recovered from government hospital, the mean should be the same. But what the Malaysia Health Ministry want to test, they said no, it's not the same. So if it's not the same, it means mu minus mu2 will either give me a positive value or negative value. It will be positive if the mean 1 is greater than mean 2, it will be positive. If mu1 is smaller than mu2, then it will be a negative value. Either ways, both are not equal to 0. So this is what we want to test, which is our alternate. Mu1 minus mu2 not equal to 0. And what is the null hypothesis? Is mu1 minus mu2 equal to 0. Yeah. And if you look into here, the sign not equal to, okay, we are using the two-tailed test. To run this test is much easier. Yeah. We can use the Microsoft Excel Analysis Tool Pack. There are 3 different types of tests available. The first one, population variance is known. We will use the Z-test, 2 sample for means. Population variance is unknown and assume unequal. T-test, 2 sample assuming unequal variance. Population variance is unknown but assume equal. We use T-test, 2 sample assuming equal variance. Yep. It's very difficult to find population, yeah, where the variance is known. And at the same time, it's not easy to justify it, yeah, if the population variance is assumed to be equal. Most of the time, the test that we'll be using is the one that I've highlighted over here, which is T-test, 2 sample assuming unequal variance. Let's try an example. We will use this example just now. Yeah, my first example. Malaysia Health Ministry is using COVID-19 test kits both from South Korea and China and received information that test kit from South Korea takes a longer hours, okay, takes longer hours to provide results as compared to test kit from China. So it's an upper tail test. Let's run the test in Microsoft Excel and see how are the results. Yeah, do we reject or we fail to reject the null hypothesis? So I have a hypothetical data here. It's COVID-19 test kit. So we have gathered data, yeah, from patients who were tested using test kit from South Korea, and we have patients who were tested with test kit from China. And over here we have the hours that it took, yeah, to generate the results. So let's see, yeah, if the two sample mean are different. So what we do, yeah, you go to your data and you choose your data analysis tool pack. So we are going to use this one, yeah, t-test, okay, two sample assuming unequal variance. You click this, okay, yeah. So they want you to find the first input range. So here, right up to South Korea. Enter. Then the second sample, which is here, China. Okay. Enter. What is the hypothesized mean difference? It's 0. Yeah, we did not include any labels. Alpha level. Remember, we always have to determine what is our alpha, yeah, the significance level. So we have selected 0.05. So I want to select an output range. I want the output to be displayed over here. And I click OK. Let me just make the table a bit more appealing. Yeah, so this is the test. Okay, this is the test here. So sorry, I wanted to highlight it yellow here. Yeah, okay. So what are the figures that we are concerned? Here, the t statistics value. Okay, I'm putting a yellow sign here. And I'm concerned about the t critical one tail. Okay, highlighted. And we are also concerned about the p value here, one tail. Okay, I'll just give it another color here. Okay, let's put it green. So we know that the t critical one tail is 1.76. And we know that the t statistics is 5.53. So you can see just now, okay, our critical value was 1.76 and the t statistics was 5.53. Yeah, and this 5.53 falls in the rejection region. Yeah, therefore we reject the null hypothesis. So there is sufficient evidence to conclude that H1 is true. Yeah. Now this is the critical value approach. We can also use the p-value approach. So if you look into the p-value, it's 3.68 e. It's 0.5 here. Yeah. So what we mean here is that the p-value is almost to 0. It's 0.0000. The p-value that we obtain equals to 0.00. So you can see the p-value is less than the alpha, which is the significance level that we selected, 0.05. So if the p-value is less than the alpha that we have selected, we say we reject the HO. So there is sufficient evidence to conclude that H1 is true, yeah, which indicates that the testing kit from Korea takes longer hours to generate result as compared to the test kits from China. Okay, we are done with the independent group. So let's look into the dependent group, yeah, which is the paired two sample test for mean. Let me share with you a few examples. Let's say if you're running a diet program or a diet plan, you would want to test on a group of people. So what you would do is that you will take down their BMI before the program and then you will record their BMI after the program. Yeah, and you expect if the program is successful, their BMI to decrease. Therefore, if we have a mean before and a mean after, which is the mean of the BMI, definitely the mean before will be higher and the mean after will be smaller. Yeah, so writing the alternate hypothesis, we can see here the mean difference MD here, mu D here, which is mu1 minus mu2, mean difference. Yeah, it will be greater than 0 because the earlier was a bigger value and later is a smaller value. And for paired 2 sample test, the H null is written in such way where the mean difference is equal to 0, where the mean before and after no changes. Yeah, no difference. In another example, yeah, new production method is being introduced and it increased the number of defects in the products. So you want to test before the new production method and after the production method. So you need to use the same number of workers who are producing the products, and you will record the number of defects contributed by each workers, and then you will make them to work on the new production method, and you will now record the defects. Yeah. So if the new production method is expected to increase the defects, so the mean of defects before will be smaller, and after it's going to be greater. Therefore, the mean difference is going to be negative. Yeah, smaller than 0. So that will be the alternate hypothesis. So in another example here, let's say for the first time you're testing a new drug on the size of a tumor, right? So this new drug can contribute to two situations. Either the tumor can be bigger or the tumor can be smaller. Yeah, so we are not sure, yeah, before and after, either bigger or smaller, but it's going to be definitely different in this case here. Yeah, so we say that the mean difference is not equal to 0. Either before, after it becomes bigger, then it will be a negative value, or after it becomes smaller, it can be a positive value. Yeah, so this is the way that you write the paired 2 sample test for mean hypothesis. Yeah, and I would like to stress again, for the null, the mean difference is always equal to 0. You can use Microsoft Excel Analysis Tool Pack, to get the paired 2 sample test for means. So the test is usually the t-test paired 2 sample for means. Let me show you. So let's take an example. We're going to use the new production method. And it said that the new production method increased the number of defects in the products. Yeah, so before and after. So after, the number of defects increases. So as the number of defects increases after, therefore the mean difference before and after is going to be a negative value. Yeah, therefore we say it's smaller than 0. And if it's going to be smaller than 0, the sign here, lesser than, we will be using lower one-tailed test. And the significant levels that we pick is alpha equal to 0.05. So you can see lower one-tailed test. You can see the rejection level, it's over here. So let's do this test in Microsoft Excel. So I have this hypothetical data, it's number of defects. So these are the workers and workers before and after. So this was before the new production technique was introduced, and this was after the new production technique was introduced. Yeah. So how do I run the test? I go to data, click on data analysis. I'll be using t-test paired 2 sample for mean. Click OK. So variable range 1, you can click on before. And then we pick variable range 2. I'm taking with the label. And you have to click label here. Hypothesized mean difference is 0. Alpha level 0.05. Where do you want the output range to be? We want the output range to be here. And you click OK. Let's make the table more appealing. So you can see over here, it's a t-test compared to sample for mean. Yeah. So what we need to look into is that we need the t statistics, we need the critical value, and we need the p-value. Okay, let's put it yellow here. So how do we interpret these results here? Yeah, we take into consideration the t critical one tail first, yeah, and we take the t statistics. So we can see the one tail is 1.79 and the t stats is negative 2.60. Yeah, so remember it was lower one tail, so therefore the critical value will also be negative sign. So we have placed the critical value here, which is negative 1.79, and we can see the t statistics falls into the rejection region. Yeah, therefore we reject the null. So there is sufficient evidence to conclude that H1 is true. So the p-value is 0.01. Yeah. So let's see what that indicates. So using the p-value approach, p-value equals to 0.01. It means that the p-value is less than alpha. Yeah, so you can see over here in this table here, if p-value is less than alpha, we reject the null. So there is sufficient evidence to conclude that H1 is true. That means the new production method or technique contributes to greater amount of defects.